Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning of reservoir modeling and simulation for CO2 storage in saline aquifer. Okay, in previous videos, we have talked about CO2 storage modeling, and the main or the only trapping mechanism is just the structural trapping. Okay, so here we have the aquifer and we can see the CO2 plume here. The CO2 is trapped because of structural effect only. Now in this series of video, or maybe in this video only, we will learn about another trapping mechanism. It is called hysteresis or residual trapping. Okay, so let's go first to our CMG launcher here. Okay, we will do what is called hysteresis modeling, okay? And we will use hysteresis as another trapping mechanism. So the purpose of this exercise is to add to the structural trapping of the base model by incorporating hysteresis trapping, all right? This trapping method uses the effect of shifting from drainage to imbibition relative permeability curves to trap the non-wetting phase, which in this case is the gas, the CO2 itself. Okay, so we will utilize the shifting from drainage to imbibition relative permeability curves to trap the CO2. All right, the first approach I want to do is here. I have this file, the base case. I want to modify this one, so I will drop it to edit. Okay, let's wait. Okay, we will edit the code using the editor. All right. Okay, so this is our code. Let's go to the top. Okay. So first, we need to change the title. Okay. The base title is CO2 injection. I want to add CO2 injection hysteresis trapping. Okay, CO2 injection base plus hysteresis trapping. By base, I mean the structural trapping only. Okay, so we change the title, and of course we need to save this one. Okay, save as. Okay, I want to save it as CO2 injection underscore hysteresis. Save. Okay, so far so good. Now we will maintain everything else except rock fluid data. Okay, we will need to change a little bit in this section in rock fluid permeability data because we want to insert the effect of hysteresis. Okay, to enable to implement the hysteresis trapping. Okay, so here we have in our rock fluid section, of course, we have relative permeability curve. All right. And here, after the rock fluid section, after the definition of rock and fluid interaction, we will go to the initialization. Okay. But I want to add something here. So I will press enter. And then I will insert hysteresis trapping, which will be enabled by the code HYSKRG, hysteresis relative permeability curve. Okay, And then I want to add value of 0.4 as the maximum residual gas saturation. Okay, so again, this will enable the hysteresis modeling, this code, and the value of 0.4 is entered to input the data for maximum residual gas saturation. Okay, so that's it. And again, we want to save. All right. And then let's go to CMG launcher and let's find our case, which is now here, CO2 injection hysteresis.dat. Okay, but yeah, so I will touch this one and then I will just drag and drop it to our machine, which is GEM, our simulation machine. Okay, so again, job process settings, number of processes 4, submit to scheduler local. This is the sub simulator version, priority, and everything else we will maintain as it is. And then we can click calculate. Okay, so after running on the gem, if you right click and click refresh, we have in our logger the second row. Okay, then the ID, second project name, default folder, and the job name is CO2 injection for hysteresis. Everything else like this one. Okay, so we can touch this one and we can look at the view log file. Okay, from the week 1 down to week this one. Total number of time steps, Newton cycles, solver iterations, and others. Material balance error, and others. So this is the result actually. Okay, time step, maximum changes, and the error. Okay, so by having this log, it means that our simple simulation, the computation is quite smooth. Everything is good. So now we can just visualize and present the result. I can minimize this one. All right, and we still have our results opened here. Okay, all right. And if we go to data sources, here is our data. All right, and we can click this button, add files, and then we will find our result. And the file will be .sr3, which is this one. Okay, we will call this one CO2 injection hysteresis.sr3, the result file. Now we have two files. Okay, the base file, the file, the exercise with only the structural trapping, and the file with this one, hysteresis trapping. Okay, and if you look at the reservoir section, we have this one, the visualization for base case CO2 injection and for CO2 injection hysteresis. Okay, and what we will do is actually touch this one and then drag and drop at the dashboard. Okay, so inside the dashboard, we will have this one as the base. This is the visualization of the base case CO2 injection. And we will do the same thing for IK2D view from exercise with hex hysteresis. I touch this one, drag and drop on the dashboard. So I will have two windows like this one. The left one, the CO2 injection, base case, and the right one is CO2 injection, base case, structural trapping, plus hysteresis trapping. Okay, so far so good. Here we can right click gas saturation, and also on the right click, we also show the gas saturation. Okay, so gas saturation and then gas saturation as well. Yeah, this is only the effect of coloring, yeah. So the highest level will be colored red, but for this one will be colored green. So let's check if we can change the color scale editor. Touch this one, edit point color. Let's change it to this one. Click OK. Click OK. Okay, should we try again? Okay. All right. Yeah, just we can maintain this one just to maybe to differentiate between this plot and this plot. Okay, so we can go to display. All right, we can click this one. So you can track the movement of CO2 plume. All right. And we can go directly to the end of the simulation by clicking this one. All right, so far so good. So you can see clearly the difference between the two. The first one, the base case, we only have structural trapping. We neglect the residual trapping. We neglect the hysteresis trapping. And you can see by disregarding the hysteresis trapping, we have CO2 plume accumulating at the top like this one. Okay, but on the right side, we honor the hysteresis trapping. We honor the hysteresis trapping. And as you can see, we still have here CO2 saturation. You can look at this value, the gas saturation, right? We have gas saturation left in this reservoir, in this aquifer section. Yeah, they cannot move because of residual trapping. Okay, here, the gas saturation is 0.05, very, very, very small. But on the right, we have 0.3 something, which means that the value, the amount of CO2 trapped due to residual trapping or hysteresis trapping is significant. And because of that, the amount of CO2 on the top is of course less than what we have on the left case. Okay, it's beautiful, right? All right, let me try again about this color scheme. Yeah, right now you can look at the difference between the two, right? The amount of CO2 trapped on the left is only because of structural trapping, but on the right, we enable the residual trapping as well. Okay, change again to this one. Okay, so anyway, it's okay. And if we go to this one, all right, we go to the reservoir section, IK to the view. And now let's say right click and we want to show gas saturation for relative gas relative permeability hysteresis. All right, and again, we want to play, right? You can look at the plum migration, right? Over time. And we can also click this one to look at the result at the end. Again, we can also prop display, and we want to show as well, for example, gas saturation for KRG hysteresis, as well as the residual gas saturation for KRG hysteresis, and this one, SG less than critical gas saturation, hysteresis dynamic trap gas saturation. Click OK, and then go to the left again. And play the simulation again. So you can read the message, the location of the block, the cell, the gas saturation for KRG hysteresis 0.55, residual gas saturation for KRG hysteresis 0.33, and also the gas saturation less than critical gas saturation, hysteresis dynamic trap gas saturation 0.31. So we can activate this view by this prop display. Okay, it's great, right? By the way, no problem here. We have the cell colored blue. So it doesn't matter what we have in dashboard where we have different color, doesn't matter. That doesn't influence our interpretation or conclusion, right? So you see, because of hysteresis trapping, because of residual trapping, okay, residual trapping, we have more CO2 trap, not at the top, but across this interval, this vertical section. And then we fast forward. Okay, and at the end, this we will get. All right, so it's great. So far, so good. Now, let's check at the time series plot. Okay, here we have data type for wells, layer, groups, and sector, others. And here we have data source, which data source we want to plot, the data, the parameter. Now we want to highlight the spatial history, touch this one. We will call the data from CO2 injection hysteresis, all right? And then data spatial history. And we want to show the CO2 trap, okay? CO2 trap. And then we can just add to new plot. Here we have the amount of CO2 trap in mole across time. So CO2 trap in mole across time. Okay, it's great. And we can also plot CO2 aqueous ions, CO2 dissolve, CO2 gas, and then CO2 liquid, CO2 in mineral form, and CO2 supercritical. All right. And then we can touch this CO2 supercritical. And then at curve, we can see the supercritical CO2 across time. Okay. And let's check as well the CO2 liquid. Okay. Here, no CO2 in liquid form. CO2 gas at curve, no CO2 in gaseous form. All the CO2 is in supercritical form. Okay, so I think that's about everything for this exercise. So in this case, we we enable, we apply the hysteresis trapping or residual trapping, which will work to trap more CO2. So in addition to structural trapping or stratigraphic trapping, we also have residual trapping to trap our CO2. And by the way, previously we do the modification in the code itself, but we can also do that in the builder. So here we have our builder, okay? And then if you want to do the builder, the modification in the builder, you can go to IO control, title, and case ID. You can change the title like the one we did in the text. We modify the title, right? We change the title to CO2 injection base plus, for example here, base plus hysteresis. So you can do that. You can click OK, and then you can click save. Save as you create a new case. Yeah, base plus hysteresis. And we also do modification in the component. I mean the rock fluid section. So in rock fluid section, you go to rock fluid options. I mean this one. All right. In rock types, and you see we have rock type properties, relative permeability tables, right? Before in text editor, we also have relative permeability table, but in the form of code in text document. Here we have in terms of user interface, but actually the essential is the same. It's this number generating the relative permeability. And if you want to add hysteresis modeling, in the text we add code, right? We add keyword, the HYSKRG 0.4. Here, using interface in Builder, we can do that by clicking hysteresis modeling and activate this one, model hysteresis effect in gas relative permeability, KRO here. Okay, values, and then if you activate this one, you input 0.4 here, or actually here, model hysteresis effect in gas relative permeability KRG values. I mean here, yeah, I think this one is good. And here you see, note the keyword HYSKRG will be supported for next release. We don't have in this current release, and what we have in this version of CMG is here, maximum residual. This should be gas saturation. So actually we cannot do that in this version. Okay, I take my words. In this current version, we cannot do that. We can only do on the text editor. We add HYSKRG 0.4, but on the next release, the next CMG release, we will have model hysteresis effect in gas relative permeability KRG values. And the second node will be maximum residual gas saturation between critical gas saturation and 1 minus critical liquid saturation SL-con, and this will be 0.4. Okay, so yeah, we can skip this one. We can go back to the editor and we just add this keyword and the value. Okay, so I think that's all. We have learned something very prestigious. I mean, very precious in this exercise. So in the next video, in the next exercise, we will add more learning. We will add more trapping, and we will do more interpretation and learning regarding CO2 storage modeling and simulation. All right, so I think that's all. Thank you so much for watching. I hope this everything is important and relevant and useful for all of us. Thank you so much for watching and see you again in the next CMG CO2 storage modeling in the next video. All right, thank you.